Hey guys, sorry about that. As you could hear, my phone was ringing. So where we left off was we were trying to find the times at which the height of this mass was going to be 1 centimeter above equilibrium, and we got to here. Okay, if you wanted to solve this without using a graph, um, what you'd have to do is divide both sides by 4, and then take the inverse sine of both sides, and then you'd have to add pi over 2 to both sides, divide both sides by pi over 2. You'd get t alone finally. Okay, but when you do that, you have to remember that taking the inverse sine, you're going to get two possible answers. The calculator is only going to give you one, and you're going to have to think about which quadrants the other ones would be in and use the unit circle and figure that out. So probably graphing is the easiest way. Anyway, either way you do it, let's see, I did this earlier, and what did I get? I got that this thing would be 1 centimeter above at a time of 1.16 seconds after we release it, and then again at 2.84 seconds. Okay, and that makes sense. It's going up. It hits 1 centimeter above. It goes up higher and then comes back down again. And so there's another time in that first cycle at which it is at that point. Okay, so these multiple solutions are having a physical consequence. All right, I hope that example helped. Again, example 3 in your text is another one. It's easier, but it's a similar sort of thing. What I would like you guys to do for homework for this section, page 555, number 1, 2 through 5. I'm sorry, number 1, number 2, 5 through 10 all, number 12, and number 13. Okay, I think that's also up on Blackboard. It doesn't look like a lot, but they're a bit challenging. Okay, let me know if you have a problem with that, and I'll try to do what I can to help. All right, the last part for this section 8.4 is going to be a video with clips from a lecture by one of my old physics teachers in college. He's funny and interesting, and he's just talking about different ways in which waves and vibrations exist in the world around us, and then I put a clip in there of him demonstrating that the period of a pendulum's oscillation does not depend on the mass in a very dramatic way. All right, enjoy, and I hope this week went well. I hope that we can continue this way for next week. I think I've got my system down. I hope it all hangs together. I think you guys are smart enough and mature enough that together we can make this work. Okay, I'm counting on you guys. Have a great weekend, and I'll talk to you next week. Bye-bye.